Okay, hi everyone. I'm going to talk you through a GCSE exam paper. This is one from OCR. It's a higher paper, and this paper was sat in November of 2018, and this one is actually paper 5, so it's the middle paper you'd be sitting, paper 2 if you like, and it's the non-calculator paper. Now, I've already done the exam paper, so what I'd like to do is to talk through my solutions, and at the end of it, hopefully give you an idea of what the grade boundaries for this paper would be. If I don't forget, which I'm sure I won't. Right, here we go. So you open the paper, hopefully it's an easy one. Let's have a look. And it is, let me zoom in. By the way, these only really work if you have the papers in front of you. If you don't have them in front of you, you're going to struggle to see it, but we'll see how we get on. Right, the first one is question 1. Work out the cube root of 64 times 2 to the power negative 1. Now, you need to know how to cube root something. So the cube root of 64 is 4, because 4 times 4 times 4 is 64. So the cube root of 64 is 4. And 2 to the power minus 1. The way I do this is I ignore the negative. So 2 to the power 1 is just 2. But if it's to the negative, it means it wants the reciprocal of that. So the reciprocal of 2 is 1 over 2, which in this case is a half. So 4 multiplied by, let's put that in, a half is 2. And there's your first 2 marks of the paper. Next one, question 1b. This is a standard form question. It says, and let me try and zoom in a little bit so you can see it, 4.3 times 10 to the power 5, add 3.8 times 10 to the power 4. You've probably learnt this in year 8 or year 9. You might have forgotten how to do it, but it's dead easy. 4.3 times 10 to the power 5 is that, what I'm pointing at, and 3.8 times 10 to the power 4 is that. You simply add them up, column addition, and then you put the answer back into standard form, because it says, give your answer in standard form. This, according to the examiner's report, this question was answered well, but an awful lot of students only got 2 marks because they did not convert the answer back into standard form. So I know that every teacher says this, but please do read every part of the question. Question 2. By writing each number correct to one significant figure, find an estimate for this calculation. So what I've done is 606.3 to one significant figure is 600. 0.312 is 0.3, and 19.93 is 20. I've then started to do some calculations, so 600 times 0.3 is 180. By the way, I found that a bit fiddly in my head. The way I did it was, I just did 600 times 0.1, which is a tenth of 600, which is 60, but here you've got 3/10 of 600, so 3 60s are 180. And then it's 180 divided by the 20, which gives you 9. And for 3 marks, the answer is 9. You must show your workings for this, so you must show this part here. If you do not, you run the risk of not being given full marks. So you must show every step of your workings. I'm going to say that sentence an awful lot during this exam paper. You must show your workings. Right. Question 3. Jeff has 2 fair spinners. So go back to what the fair means. It means not biased. He spins both spinners and multiplies the numbers on each spinner. So there's the 2 spinners, and here is the table which he has started to fill in, and hopefully you can see what he's doing, that he's multiplying them. So 1 times 2 is the 2, 7 times 2 is the 14. So you get 1 mark for doing 9 times 4 and then 9 times 5. For my money, that is the easiest mark on the paper. Please don't lose that. Now, Jeff wants to work out the probability that the outcome of the multiplication is an even number or a prime number. So when he says that, he means these numbers here. These are the outcomes of the multiplications, because when you do your multiplications, these numbers are the outcomes. That's fairly straightforward. So here's his working. So he says the probability the outcome is an even number is 6 over 12. Let's just check that. There's 12 numbers here. Are 6 of them even? 1, 2, 3, 4, 5, 6. So yeah, that's correct. The probability the outcome is even is 6 over 12. The probability the outcome is prime is 3 over 12. Let's check that. This will test our prime number knowledge. There's 2, 3 and 5. They're the prime numbers there. None of the others are. You can pretty much tell that because they're sort of multiples of 3s and 7s and 8s or 9s and 4s and things. So there are your 3 prime numbers. So he works out that the probability of the outcome of the multiplication is an even number or a prime number is 9/12 because he has added these two together. Now it tells you he is wrong. So if you haven't spotted it so far, he is wrong. Explain what he has done and then give the correct answer. So what he's done is, if it's an even number or a prime number, those two outcomes, they're not mutually exclusive. For example, the number 2 is both an even number and a prime number. So the real answer should be 8/12. And what I'm going to do up here, just to show you that, I'm going to circle the ones that are even and are prime. Let's use a bit of green, I think. So even or prime. So let's do my evens first. So it's 1, 2, 3, 4, 5, 6, and obviously 2 is prime, but we circled it already because it's even. That is a prime number, and that is a prime number. So the probability that he spins probability of the outcome is an even number or a prime number is 1, 2, 3, 4, 5, 6, 7, 8/12, and please give the correct answer at the bottom. So you get 2 marks for explaining that. Next one, question number 4. Let's have a look how we're getting on. A bit of density here. A solid metal block has a mass of 500 grams and a volume of 125 centimeters cubed. Work out the density of the block. First thing I would do, and hopefully you've learnt this triangle over here. It's the way I do it. There are other methods available, but you can do it whichever way you want. Work out the density. So density is mass divided by volume, which I've done here. So the density is the mass, which is 500, divided by the volume, which is 125, and that gives you 4. Now, you get 2 marks for that. You actually get 1 mark on this question for giving the correct units to the answer. And that happens quite a lot on these papers, so do look out for it, because look, they don't give you any units here. So you actually get 1 mark for the correct units. Question number 5. The depth of water in a garden pond is 57.8 centimeters. The depth increases by 0.3 centimeters each day. Assume the depth continues to decrease at the same rate. After how many days will the depth reach 54.2? So what I've done is worked out the difference. So it started on 57.8 and it finishes on 54.2, so I've just subtracted them. So it actually falls by 3.6 centimeters. Now if it's falling at 0.3 centimeters per day, you should hopefully be able to work out that is 12 days. Part B. If the depth of water decreases at a slower rate, what effect will this have on your answer to part A? So at the minute the it could be draining away, evaporating. I don't think we're quite told. It just says it goes down. At the moment it's going down by 0.3 centimeters a day. So if that decreased at a slower rate, maybe 0.2 centimeters a day, what effect would it have on this answer here? Well, if it's draining or if it's losing water slower, the answer would be bigger as it would take longer. Question number 6, I think we're on now. Sally has got some ribbon and she's got 30 feet of it. A foot is 12 inches, in case you forgot. So usually the length of a ruler, in case you don't know what a ruler is. She cuts strips each of length 2 2/5 of a foot, or 2 2/5 feet from the ribbon, and she says she can cut 13 of these strips from the ribbon. So there's 2 ways of doing this. If your mind's gone to mush, look, here we are. Here is my 2 2/5 times table. So I've gone up in 2 2/5 all the way. So look, that's 1 bit of ribbon, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, she can't do 13 because it goes over 30. So she can only cut 12 bits of ribbon, and she has got 1 1/5 of a foot left over. But that will get you the the full marks, full 4 marks for this. It's not a particularly nice mathematical way of doing it, but it gets you the answer and it gets you the marks, and in these exam papers it's the marks we want. The other way of doing it is by doing a bit of division. So we're going to do the 30 and we're going to divide it by 2 2/5. Here are my workings for it. I'll briefly talk you through them. I won't wave the paper around anymore. So to divide fractions, 30 is actually 30 wholes, so we'll leave it like that. And when we divide fractions, we keep the first one the same, we flip the second one over, and we change the divide sign to a multiply sign. Some of you might remember that as KFC, keep, flip, change, but however you remember it. 30 times 5 is 150, 1 times 12 is 12. Simplify that, divide both sides by 2, well, you can divide it by different numbers, but I've done it by 2, to 75 over 6. And divide both of those by 3, so you get 25 halves, or 25 over 2, which is 12 and a half. So she can only cut 12 and a half strips. Either one of those is the correct answer, but you must, at the end, write a line. And I'll be honest with you, if you wrote a line like this, no, she can only cut 12 and a half strips, the chances are the examiner will look at that and look at your workings here and give you the full marks and probably move on. Because if you've worked out it's 12 and a half strips, or she has 1 1/5 left over, you must have got the workings correct to get there. Okay, question 7, here we go. Emily spends £2,400 on a holiday in 2017, and that was 20% more than she spent on holiday the year before, in 2016. Calculate the amount she spent on the holiday in 2016. So this is a reverse percentages question. Now, we want to work out how much she spent in 2016. So what we know is, in 2017, she spent £2,400, and that was 20% more. So what I've done is called that 120%, because the 100% is what she would have spent in 2016, but then we've added on the 20%. So once you're happy with that top line, you can then do a little bit of maths here to work out what 100% of the cost of the holiday was. So I've divided by 12 and multiplied by 10. It's a non-calculator paper, so I'm trying to keep it fairly straightforward. So that tells you 100% of the cost of the holiday was £2,000. That's the answer, 3 marks. Now the nice thing about reverse percentages question is that you can check your answer. Because if that's what she paid in 2016, and I might do a little note on that, 2016, and you're told the following year she spends 20% more, well, if you add 20% onto this, you actually get 2,400. 10% is 200, double that, 20% is 400, add it on, 2,400. Next question is question 8. Here we go. The table. Let's zoom out a little bit. The table shows the number of computers sold in Tom's shop each quarter from 2015 to 2017. When businesses talk about this sort of thing, each quarter is a quarter of a year. So quarter 1 will be January, February, March, April, May, June. Oh, got some bit of ink on my hand. April, May, June, July, August, September, October, November, December. Complete the graph using the information for 2017. So what I've done, look, if you look at it, 1 goes up to 13, so goes up from 1 up to about 13. So that's what you've got to do over here. So 1 goes up to 27, 2 goes up to 40, and so on. I'd plot them using crosses, although you probably use points here and get away with it, but I think crosses are always more accurate. 2 marks for plotting those. You do need to connect the lines up afterwards. Don't forget, again, your trusty ruler. Make sure no sloppy maths here, please. Now, part B. Tom adds the 3 results for quarter 1, and he adds the 3 results for quarter 4. And Tom says the ratio of the total number of computers sold in quarter 1 compared to quarter 4 is 2 to 5. I'm not going to worry about the ratios here to start with. The first thing I'm going to do is add up the results for quarter 1 and then the results for quarter 4. So let's do a bit of adding up. For quarter 1, it is, let's look up here, it is 13, add 20, add 27, so 13, add 20, add 27, and for the quarter 4s, it is 45, add 47, add 58, which is down here. So that's them added up. You've probably got 1 mark for doing that. And now you're going to put it into a ratio. So it wants quarter 1 compared to quarter 4. So I suppose above here you should write the ratio of quarter 1 to the ratio of quarter 4. Simplify the ratio, is 2 to 5. Is he correct? Yes, he is. And again, it says show your reasoning. These numbers here, that's my reasoning. And you could look at that and think, yeah, I know what's happened. Please label it, show you're doing quarter 1s and quarter 4s. Don't just assume people know what you're doing. Maths is all about communication, so please make it as clear as possible. Question number, there's a part C to this. Let's have a look. Part C. Make 2 comments about Tom's sales over the period 2015 to 2017. Now, as long as you're making an intelligent comment, you tend to get the marks for this. Don't just write things like they're going up. You've actually got to be a bit more specific. So let's have a look what I put. I put for comment 1, sales were stronger in quarter 4 and weaker in quarter 1. And I think I've evidenced that from these figures down here where we added them up. Sales are definitely stronger in quarter 4. Possibly because Christmas is coming up, who knows. And in in comment 2, I put overall sales are increasing year on year, and if you're going to make that comment, you need to back it up. So there's the overall sales there, and I got these just by adding up the how many computers he sold in 2015, and so on. Tom predicts he will sell more than 60 computers in the 4th quarter of 2018. So let's have a look at the 4th quarters so far. So the 4 quarters are 45 to 47 to 58. So it's gone up by 2, then it's gone up by 11. So if you carried this one across 2018, would he sell 60? It looks like he probably will. But what assumption has he made? And he's assumed that the trend in sales will continue at a similar rate. It's only 1 mark. You don't need to go into the details of what might affect it. But you've got to assume that the trend in sales continues at a similar rate. Right, now we're on question 9. Rearrange the formula to make y the subject. So that means you want to get the y on its own. So here we are, look. I should probably write down what I'm doing in each one of these. So that's what we start with. And what I've done, I'm trying to unpick this y squared here. So I want to get rid of this add 7. And you do that by subtracting 7 from both sides. I want to get that to be a normal y. So how do you undo a square? You square root it. So you've got the square root of x minus 7 equals y. Don't forget, when you square root something, the answer could be positive or negative, hence my little positive or negative signs down here. 2 marks for that. Question number 10. Right, bit of transformations here. Triangles A and B are drawn on the grid. Now I have answered them, but please watch my working through it. Draw the image of triangle A after a rotation of 180 degrees around the point 0, 0. So this is the first one here. So I'm going to rotate this 180 degrees around this point. Please, when you do this, tracing paper will be really handy. You can obviously see I've done it, but I want to show you how it's done. There's my centre of rotation, point 0, 0. I'm going to draw around this. It doesn't have to be super neat, but, you know, do your best. Right, and because it's 180 degrees, it doesn't matter which way it goes. I'm going to choose to go anti-clockwise, just because my hand's in the way if it goes the other way. And hopefully you'll see this one landing on there. There we go. You get 2 marks for doing that rotation, which seems a bit generous, but there we go. Next one, draw the image of triangle A after a translation by the vector 2 minus 7. So translations, that's when you slide it around the grid. What I've shown you here is the top number is you either go sort of left or right, and the bottom number is up or down. If it's positive, you go to the right. If it's negative, you go to the left. If it's positive, you go up. If it's negative, you go down. So we're going to shift this 2 spaces to the right, and then we're going to shift it 7 spaces down. What I do is pick a point, so let's pick, I don't know, this point here. So 2 spaces to the right, 1, 2, and 7 spaces down, 1, 2, 3, 4, 5, 6, 7. So that point goes along there and down there, and I'm going to redraw the triangle from here. If you want to be ultra safe, you could do that with all the points, and you'll see where it goes, but you don't really need to, but you can if you want. So that's another 2 marks for that one. Part B, describe fully the single transformation that maps triangle A onto triangle B. Right. Actually, there was a bit of multiplication earlier, which told you, which got you a mark. You're probably even easier than that. How do you get from A to B? Your first mark is enlargement, and if you've written that and only that, you get yourself 1 mark. The rest of it is a little bit tricky. I'll show you what I've done. So what I've done here, I've drawn my ray lines back through A, so I've connected these points on the bottom up, and you see it goes along there, and then I've connected those 2 points up, and what I'm interested in is where they cross here. So I can say it's been an enlargement. Now it was 2 across, but it's now 1 across. So what's happened? It's halved. So it's enlargement, 1 mark, scale factor a half, 1 mark, and the centre of enlargement is the point -1, 2, because that is your centre of enlargement. So -1, 2, 3 marks, and that's how you get them. Okay, question 11. The price of a washing machine is reduced by 20% for a sale, and afterwards the price is increased by 30%. Joachim says the washing machine is now 10% more expensive than it was before. So what Joachim's done is just taken off 20% and added 30%, and he thinks there's 10% difference. He is wrong. So the question says, explain Joachim's error and work out the correct percentage change in the price of the washing machine. So his error is he has not calculated 30% of the sale price, he's calculated 30% of the original price. Here's my example to try and talk you through it, but this might make more sense. So, assume the washing machine costs £100, a 20% reduction would mean it costs £80. So it's been reduced by 20%. A 30% increase, so add on 30% to £80, so that's 8 at 8 at 8, what's that, 24, and that would be £104. So it's not increased, well, it has increased by £100 to £104, but it's not a 10% increase, it is a 4% increase. And that is what you need to say here. Now look, it is 6 marks for this, so you must be showing workings. I think if you just wrote that top line and did there, you'd probably get 1 mark. You need to be showing how you've worked this out. This is the way I do it. I love picking an example price and working from that because I find it a lot easier in my head. Those of you who work slightly differently, here's another way of doing it. That's 0.8 is the multiplier for a reduction of 20%, and 1.3 is the multiplier for an increase of 30%. So if we do 0.8 times 1.3, I did 8 times 13, you get 1.04, and 1.04 is the multiplier for a 4% increase. So there is a simpler way of doing it, but there are 6 marks for that, so you really need to be picking up marks, picking up as many marks as you can from that one. Right, question number 12. Moving on. Here's a sector of a circle, and it says that that point there is the centre of it, and it's got a radius of 6, and the length of this arc, A to B, so this arc here, is 5 pi centimetres. So this is going to be a circles question, but we're going to be giving answers in terms of pi because you are not allowed to use one of those. Now, find the area of the sector. Give your answer in terms of pi. So we need to work out the area of this. Usually, when you get a question like this, there's often an angle in here. So then you'd know where you could put that angle there over 360, then work that out as a fraction. But we haven't got that option here. So what I've done, look, we know that's 5 pi, the sort of length of that arc, but I want to work out the whole circumference. So circumference is pi times diameter, and in this case the diameter is 12 because 6 is the radius, so so that means 12 is the diameter. So the circumference of the whole circle is 12 pi, and this bit is 5 pi. So the area of the sector will be 5/12, 5 over 12, the area of the whole circle, because this length here is 5/12 of the circumference of the whole circle. So the area of the whole circle is pi times the radius squared. Pi times 6 squared, because that's the radius, is 36 pi. So we want 5/12 of 36 pi. Well, 5/12 of 36 is 15, so the answer is 15 pi centimetres squared. I suppose this question is fairly straightforward, but only if you see that you've got to start working out the circumference. If you don't notice you've got to work out that, the chances are you won't get any marks for it. If you're not sure what to do, try and work things out that you know. I mean, you could have actually worked out the area of the whole circle as well, so that would have got you 1 mark for it. So if you're not sure, do try and pick up some marks. Next one, question 13. In the diagram, ABC is a right-angled triangle. P is a point on AB, so that's well, it's there, you can see it. And that's 40, and that's 20, and that's 30 degrees. Show that AC, that angle there, that length there, sorry, is 20 meters. So it's actually given you the answer, but you've got to show how you got it, and you get 3 marks for it. Now, you can only really do this if you know your exact trig values, or how to find them out. I've done a little diagram down here, so let's have a look. So there's the triangle ABC. We know that's 30, that's 40, and we know that's 20, but we just called it X for the time being. We're going to use a bit of trigonometry to work this out. So label my sides. That's the opposite, because it's opposite the angle. That's the hypotenuse, because it's alongside, and that's the adjacent, because it's the other one. So sine, well, you're going to use sine, because sine is opposite divided by hypotenuse. And look, well, I want to know the opposite. I do know it, but we're going to prove it. And I know the hypotenuse. So which ratio has opposite and hypotenuse in? It is sine, there. So sine 30 is opposite over hypotenuse. Sine 30 is x over 40, because the opposite is x. Now, you need to know that sine 30 is a half, because then you can just put a half in there. So a half equals what over 40? A half is 20 over 40. So that is there's your 3 marks there, because you've shown that AC is 20 meters. It could have said work out the length AC, and you would have had to work it out in the same way. But because it says show that, it is asking for the quality of your workings, and I think that's fairly tidy. Part B, find the length of PB. And what I've done, I've drawn it down here. Look, so I've got everything on it that we know. So PB, there we go. So what I've used a bit of Pythagoras to calculate PB, to calculate the length AB along here, because ignore that line for a moment. The whole thing is a right-angled triangle. So in here, look, there's my Pythagoras' theorem. I don't really want to talk through it, because you should know how to do that. But again, do show your workings for it, because you will get marks if you make a mistake. And I've worked out that the length here from A to B is the square root of 1200. Now, it wants the answer in this form: A brackets root 3 minus B close brackets. So there's some surds going on. So let's have a look at the square root of 1200 and see what we can do. And there's a few workings here, hopefully you can spot. So I'll talk you through them. The square root of 1200 is the square root of 12 times the square root of 100. There are other ways of doing this. This is my way. And that is 10 root 12, because the square root of 100 is 10. So it's 10 times root 12. 12 you could also break down a little bit more as well, because 4 times 3 is 12 and 4 is square. So 10 root 12 is 10 root 4 root 3, and root 4 is 2. So 10 times 2 is 20, so it's 20 root 3. So AB, that's the whole length there, is 20 root 3. So the length from B to P is 20 root 3 but you take away that 20. So it's 20 root 3, take away 20, and I've factorised that because it wants it in this form. So 20 is common here and here, so it is 20, open brackets, root 3 minus 1, close brackets. 5 marks. That's difficult. I had to look at that for about a minute or two before I worked out what it wanted us to do. The thing I would suggest is just start having a bit of a play with it. If you can use Pythagoras, which I think you should be able to spot really, you can use Pythagoras, right angled triangle, no two other sides. Work it out. Chances are you'll get 2 marks for getting this far, and then if you're good at your surds, then you can have a bit of a play around with it over here, or maybe on some scrap paper or something. Right. Okay, question 14. This is all about graphing inequalities. Well, they've already been graphed, but it's about being able to read them. So, let's have a look. The diagram shows the lines of y equals 2x plus 1, which is that one there, and 7x plus 4y is 28, which is that one there. Ignore this for a moment. Let me talk you through it. Now, the region that satisfies the region R satisfies these inequalities. So we've got that line drawn on the graph, it is that one there. We've got this one drawn on the graph, it is that one there. But we haven't got this one drawn on the graph. So this says y is greater than 1. So I've drawn the line y equals 1, and that's the line here. Now, hopefully you can see this all right on the video. That's actually a dotty line, and I want you to see why. It says on the other two that y is less than or equal to, or in this case it is greater than or equal to, but this one, it is just greater than. So it cannot be equal to it, so that's why I've done the dotty line. Now, let's have a look at what I've done here. So the first one, y is less than 2x plus 1, so if it's less than it, the region R must be anywhere below this line, so anywhere down here. This one here, 7x plus 4y is greater or equal to 28. I prefer it when you've got y on its own. So I've done a little bit of rearranging here, taken off 7x from both sides, divided by 4. So I ended up with y is greater than or equal to 28 minus 7x over 4. So it's greater than, so that means it must be above this line. So anywhere up here. So far we know it's below this line, it's above this line, and last of all it is greater than, it is above this line here, because, have I written that somewhere, so the region is above the line because y is greater than 1. So here's my line, so it's above there. So it's either below that down here, it's above that up there, or it's above this line up there. So that is it, I've labelled it R. You don't have to do that. What you could do is actually shade it in. That's going to look like a scribble, but please do it a little bit more neatly. I don't know if this is showing up or not, but there we are, look, I'm shading in that region there. So you could have done that as well, but just make it crystal clear what it is you mean. Question 15, a little bit of data here. The cumulative frequency graph shows the information about the marks scored by a group of 80 students in a test. Find the interquartile range. If you've done interquartile range, you will know that it is calculated by doing the upper quartile subtracting the lower quartile. So the median is 80 students. The middle one, the median will be 40, but the upper one is 60. So you draw a line from here, the upper quartile, hit your cumulative frequency graph, and you come down, and that's 74. And the lower quartile, same thing, is 52. So the interquartile range is 74, take away 52, which gives you 22. You get a couple of marks for that. It's worth knowing how to do that skill. Part B, the ratio of the number of students passing the test compared to failing it is 4 to 1. So look, passing 4, failing 1. Find the minimum mark needed to pass the test. So if the ratio is 4 to 1 and 80 students sat it, what I'm going to do is just work this out. So I'm going to divide 80 by 5, because 4 and 1 is 5. So that tells me 16 people failed the test. So 16 there. and 4 lots of 16, which is 64 people, passed the test. You don't actually need those numbers there, but it's interesting to know. So 16 students failed the test. So what you do, go back to your graph, you draw a line coming along from 16, careful it goes up in 2s, and then you go down, and that number that hits there is 48. I think the mark schemes will allow 49 as well, but 48 or 49 is absolutely fine. So that means the pass mark for it was around 48 or 49. I put 48, which is absolutely fine. Moving on, question number 16, sequences. So here's a sequence: 5, 5 root 3, 15, 15 root 3. Work out the next term. What you need to do is spot that it's been multiplied by root 3 each time. If you want to write that in to make it clearer, you can. Now it's probably quite obvious that 5 times root 3 is 5 root 3, but where people lose it is they think, well, 5 root 3 times root 3 is 15, but don't forget, root 3 times root 3 is 3. So that becomes 5 times 3, which is 15. So you need to multiply 15 root 3 by root 3. Root 3 times root 3 is 3, 15 times 3 is 45. That's where your 1 mark comes from. Part B, find the nth term. It's a bit of a fiddly one, this, but I'm going to try and explain how I did it. So the first term is 5, then it's 5 root 3. Now, because you're multiplying by root 3 each time, obviously root 3 times root 3 is 3, so up above the third term, look, is 15, but I've just kept it as 5 root 3 root 3, then it's 5 times root 3 root 3 root 3, and so on, just to show you what's going on here. So the first term is 5, and the second term is 5 root 3. You're clearly going to be multiplying by root 3, because that's what happens. So what I've done is, excuse me, that should be n now. What I've done is, my nth term is 5 times root 3 to the power of the number in the term, so in this case that's the first term of the sequence, minus 1. So that's why I put 1 there. So 1 minus 1 is 0. Anything to the power of 0 is 1, so that's why that one is 5. But the next one is 5 times root 3 to the power of n minus 1, which in this case is 2 minus 1. 2 minus 1 is 1, so root 3 to the power 1 is just root 3, so it's 5 times root 3, which gives you the 5 root 3. I hope you can see what's going on there each time. That is a slightly tricky one. That's the clearest way I could think of explaining it. If you can't think of a clearer way, please do use the comment section at the bottom. Question 17. The diagram consists of 3 mathematically similar shapes. The height of the shapes are in the ratio of 1 to 4 to 5. So, key word here, similar. For shapes to be similar, the corresponding sides have to be proportional. So basically they form the same ratio. So we don't actually know how high any of these shapes are, but we do know that the bigger one is in the ratio of 5 to 4 to 1, and the answer is find the ratio of the totally shaded area to the totally unshaded area. So what I've done is this. Let's look at the shaded area first. That's the sort of greyish one, sort of in the middle. Is this one around here? The ratio of it is 4 high. So what I've done is actually just done 4 times 4, because they're all the same shape and they're similar, so you can get away with just pretending it's going to be like a square. So 4 times 4, that will work out fine. So 4 times 4 is 16, but of course we need to take away this one in the middle. We can do the same thing. 1 times 1 is 1. So 16, take away the 1, gives you 15. So what I'm saying is the area of this shaded bit around here is going to be 15. I don't know if it's 15 what, but according to the way I'm doing it, that's how it would work out. Now the unshaded area, you want the big one, but then you want to subtract the shaded area from that, because that's obviously, it is shaded, it's not unshaded, but then you need to add on that one in the middle. So that's the area of the big one, subtracting the area of the shaded one in the middle, then you add on the unshaded one in the middle again, which gives you 10. So the total shaded area is 15, total unshaded area is 10, so it's 10 to 15. Simplify that, you get the ratio of 3 to 2. I think that's a really nasty question. Well, no, I shouldn't say nasty, it's a challenging question. Again, you need to spot that they are similar shapes, and you don't actually know the lengths of them, you just know the ratio. So when you get into your head that you're not working out actual sizes of the shapes, the question isn't too bad. But there's my workings. If you want to pause it to have a closer look, you're very welcome. Question 18. Let's zoom in a little bit so we can see it. So write x squared plus 4x minus 16 into the form of x plus a all squared minus b. So this little bit here is called completing the square, which is what we're going to do now. So to complete the square, what you have to do is you put it in a single bracket, so x is going to go there, you half this value, which gives you the 2, and then you square it. And that's the first thing. You complete any square like that, you keep the value of x there, and you half this value, it goes in there. So x plus 2 squared, that would look like, I'll try and write it down if I can, that would look like x plus 2x plus 2. So you can multiply that out, and it gives you x squared plus 4x plus 4. Now, you need to spot that actually up here, look, x squared, oh yeah, happy days, that's all good. 4x, oh that's all good. Oh god, it should be minus 16. So how do you get from positive 4 to minus 16? You need to subtract 20. So the answer it's looking for is x plus 2 in brackets, all squared, minus 20. And that will get you the 3 marks. It's worth asking your teacher how to do that skill, because it comes up pretty much every year. Right, the next one. Solve the equation x squared plus 4x minus 16 equals 0. Give your answer in third form as simply as you possibly can. Right, the answers are there. Let's try and talk through what I have done. So, hopefully you'll notice that this equation here is the same as what we had up here. So we've actually already done some work on it, because x squared plus 4x minus 16 is x plus 2 in brackets squared minus 20. So that's what I've done here. I've just replaced that with that because it's the same, equals 0. Now we can start to solve it. So what I've done is I've added on 20 to both sides, which hopefully you can see there. I then square rooted both sides because I want to undo this squaring. So you've got x plus 2 equals root 20. Root 20 is root 4 root 5. And the square root of 4 is 2, so it's 2 root 5. So I carry on up here, x plus 2 equals 2 root 5, and then I've subtracted 2 from both sides because I want to get x on its own. So x is 2 root 5 minus 2, but don't forget when you square root something there can always be a negative answer, so it's positive 2 root 5 minus 2, or it's negative 2 root 5 minus 2. If you're good at your algebra, that's not too bad, but it is a fiddly one. It might take a little bit of time to get it done. Now, underneath it says sketch the graph of y equals x squared plus 4x minus 16, showing clearly the coordinates of any turning points. I'm going to underline that because some people just sketch it and they don't get any marks. 3 points for this. So, first things first, we have solved this equation. So the values of x are 2 root 5 minus 2, which is there, and it is negative 2 root 5 minus 2, which goes here. I know this one goes here because I can, in my head, this number here, 2 root 5 minus 2, is bigger than minus 2 root 5 minus 2. And this is where the graph crosses the x-axis. So I don't know exactly if it could go there or it could go a little bit closer. That one could go a bit further there, but it goes something like that. You don't have to worry too much about it. Now it crosses the y-axis at minus 16, and you know that because it says minus 16 here. That's where it crosses the y-axis. So you can plot that point on as well. So far we have got that point, that point, and that point. This point here, this is what completing the square is not all about, but it's what it's about. It shows you the turning point of the graph at the end. So the turning point of the graph is at negative 20, which is down here, and hopefully you'll spot this as well. It'd actually be negative 2, negative 20, because of what we've got here. I hope that's fairly straightforward. Well, it's not straightforward, but I hope you're okay with it. If you're not okay with that, there are a lot of marks on this page, 10 marks, so you do need to go back and look at this skill again. Okay, question 19. The diagram shows a circle. Oh, circle theorems, this question is. You can read this if you want, but it's on the circle, basically. Work out the value of x. Right, point O is the centre, it says so in the question, and that's a radius, and that's a radius. So, what we know already is that that length is the same as that length. So what you've got there is an isosceles triangle, and you learnt about them in probably year 7 or year 8. So you can work out that the missing angle x is 66 degrees. It's 2 marks. You must say in an isosceles triangle the angles at the end of the two equal sides are the same, and you also must show the calculation you've done. It's not enough just to put 66. You'll get 1 mark at best. So please don't let yourself down for such an easy question. Next one, work out the value of y. So y is there. So angle ADO. So I'm going to work out this angle here. AD. Oh, you can't see it. ADO is there. That angle in there. Well, to work it out, what I've done first of all is I've spotted there is a quadrilateral in here, and what you'll hopefully know is that opposite angles in a cyclic or cyclic quadrilateral add up to 180 degrees, or they're supplementary. So this angle here, all of it, I'm doing it in pink, look, is this add 82 gives you 180. So that means 180 minus the 82 gives you 98. So all this in here is 98, but obviously you want just this bit here that the pen is on, so you do 98, take away the 57, that gives you in there 41. Let's try and write that in with my big chubby pen. 41, just about, there we go. So we then know that angle there is 41. What we've got here is a tangent to a circle, and it's meeting the radius. So we need to say when a tangent to a circle touches the radius, it makes a right angle. So this angle in here is a right angle. So that's a right angle, 90 degrees, it is 90, subtract the 41. Here are my workings down at the bottom. So the answer is 49 degrees. 5 marks for circle theorems. Hopefully you should be getting those. Right, and the last question. Usually the last question is really, really horrible, and this paper it is no exception, but the good news is there are easy ways to get some marks out of it. So let's talk ourselves through it. Prove that all of this is a perfect square. What on earth is that all about? Well, do you know what? When I looked at this, I thought, I actually don't know what it's on about, but I need to do some work. So what I've done, and this is what you can all do, I've multiplied out those brackets. There you go, 2 double brackets next to each other. It gives you 6x squared plus 7x plus 2. You can probably get 1 mark for that. I've done the same thing here, multiplying out a single bracket. So it's x brackets 3x plus 5. So multiplied it out gives you that. And at the end, you've just got plus 2. So I've then added that to that to that. So 6x squared at 2x squared is 9x squared. 7x at 5x is 12x. Plus 2 gives you 4. You've probably got half marks if you've done that. And to be fair, on this paper you need about half marks to get yourself a grade A. So you're well on the way if that is what you have done. Let's keep moving on. So we've got to work out it's a perfect square. So what I have done here is I've factorised it. So this is factorising a quadratic with a coefficient of x squared. Nasty business for some of us. So what I've done, and I hope you can see it, I call this the window box method. if you've seen this before, it's quite straightforward. If you haven't, and you've got a different method, use the other method. Don't try and learn this. Use the method that's good for you. So we're going to factorise this, put it into brackets. So A is 9, so that is the value of A there. B is 12, and C is 4. And you also need to work out the value of AC, so 9 4s are 36. So here's my little window box. You always put C in this bottom right hand side corner, so in this case it's positive 4 or plus 4, it goes in there. Next you need to find two numbers that add up to make B, add up to make 12, and multiply to make 36, which is AC, and those numbers in this case are 6 and a 6. So you put plus 6x in there and plus 6x in there, and you know 9x squared goes in here because that's what you've got here. All you need to do then is to work out what numbers could possibly go here and here and here and here to make it work. Sometimes there's more than one option. In this one, I don't think there is. So the answer is 3x plus 2, brackets 3x plus 2, and hopefully you'll notice 3x plus 2 times 3x plus 2 is 3x plus 2 all squared, because you're multiplying it by itself. So it's a perfect square because you're multiplying it by itself. 6 marks for that. All of you should be able to get that top bit done, and the bottom bit is only if you're confident with it. But again, the big trouble with this question is people will just leave it. They won't attempt this question because it looks too complicated. Look, it's 6 marks for this. Start multiplying out brackets. You learnt that in, I don't know, year 8 or year 9. Add them up, put them all together, see what happens. Not sure what to do. You've got 10 minutes left. Oh, he said something about factorising. Maybe I'll have a go with that. Looks like something I could factorise, and whatever method you've got for that, you can do it. At the bottom is a part B to this, only worth 1 mark. Gemma says the equation, so it's all the equation, equals minus 12 has no solutions. Explain her reason. And the reason is you cannot square root a negative value. And the reason, the key bit here, that this bit is minus 12, because if you imagine you had, it's up the top here now, but this bit here equals minus 12, or when you wanted to move the 4 over to this side, it's going to make it negative. So you cannot square root a negative value, so that equation has no solutions. Right, that is the end of the exam paper. I hope it makes sense. If I haven't made sense on any questions, I do apologise. Please go and ask your teacher and say I didn't explain it very well, and they will help. Just give you a rough idea of the grade boundaries for this one. Just looking at it now. Let's start from the top, shall we? If you want to get grade 9, it's out of 100. You've got to get 79, so let's call that 80. If you want to get a grade 8, which is your old sort of A star, you've got to get 63 out of 100. To get grade 7, which is the old school A grade, you need to get just under 50 marks, 47 out of 100, and that's achievable, I think, for everybody sitting this paper, if you do your revision. To get 6, you've got to get 38 or above, and to get a 5, you've got to get 30 or above. I don't really want to go much below there, because if we're looking at that, then we need to be thinking about if this paper is the right one. Thank you for watching. I hope that was helpful. Take care, guys. Goodbye.